In this video, I want to talk about the structure of the Mendel Falcon and the design considerations that went into building it. First off, as you can see, it is made of 3/4 inch melamine particle board, and it did this for a couple reasons. One of them is cost. This stuff is pretty cheap. I got a 4x8 sheet for like $40, and I used about half of it for this machine. So very reasonable on that front. And then assembling it, it just used typical decking screws. So very, very sturdy, very rigid, very easy to assemble. Another reason I used this material is because it fit well with some of the tools I had on hand. I don't have a laser cutter at my disposal, and I didn't want to order parts online for a printer kit. I just wanted to build something and be able to do it in my own shop. So basically I came up with this, and it is really, the design is really optimized to, I guess, leverage the capabilities of a table saw to make a very square machine. And to describe that in a little more detail, you really pay attention to your order of cuts, and you pay attention to which edges you're putting against the fence, which ones you've cut, like which edges were on the cut side of the waste piece. There's a few tips and tricks, a few tricks of using a table saw that really increase your results, and I try to leverage as much as possible in building this machine. Also, I used a dado blade to align certain aspects. So if you look, you have the base plate, which is perfectly square and has one piece that must be really square. And there's other pieces like this diaphragm plate and these stiffeners. They are in a dado groove to keep them perfectly perpendicular and parallel as needed. And also these Z-axis slide holders, they are perfectly parallel because they are in dado slots that were cut on a table saw. And those are very, very, very good, like very parallel and square. Stuff like that. Another thing I did on this is I didn't want to have too much calibrations and adjustments required. I've seen like other machines, like most notably the Mendel 90 and the Prusa i3, both of which I had a lot of inspiration from. But there's a few things that I wanted to do a little bit differently. And one of them was the way the slide rods are mounted. They both have separate mounts, printed mounts that you attach the slides to. And they also have them on the y-axis as well. And to make them square and parallel, it takes adjustment. And while that's part of the design, it's perfectly reasonable, nothing wrong with that, I wanted to try to do it without that. And I think that I have a pretty good solution for that, which has really good results as well. And it's basically just leveraging a drill press the correct way. And to do it, all you need is a very simple jig. Basically it's a 90-degree fence. You put the piece in, drill a hole, put a spacer between it, drill the other hole, flip it, do the same thing, and you can do it for both pieces. And when you're done, assuming both of these pieces were the same length, which they will be if you use your table saw, then you will have 4 perfectly inline holes, and they will be spaced perfectly. Like the spacing between these two and the spacing between these two holes will be perfectly, like they'll be exact. And then the second piece you build will be will be basically the same as the first piece. So If you do that, and if you have a good board, which you've already verified from previous steps, you will end up with a very, very good results. Those slides, they're perfectly parallel, as well as the y-axis. They're parallel to each other, and they're square with the base, which is exactly what you want. So stuff like that went into the design of this machine, and it looks like it's a little complicated. There's a lot of more parts, and it just looks more substantial as far as construction. But in reality, when you're getting into it, it's not that bad. It's actually very fast, and running a couple extra runs through a table saw takes no time at all. It's just zip, 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 you're done. The things that take the longest is setting up the jigs to like cut out these grooves with the router. I had to cut out the main hole in the middle because that's just one piece. I cut that out with the router. And the part that took the longest was just setting up the jig, which even then that took like 15 minutes to set that up. So it's really, really, really fast. And as probably most of you know, the real time involved in building a 3D printer is not in the actual framework of it, but is rather in the calibration and getting good prints. It's setting up the software and the settings, and that's where all the time comes in. So anyways, I think this is a pretty good design. It's really, really sturdy in all directions. I can lift up on one corner and I could set things underneath it and rock it, teeter it on both sides. It won't deflect. I've also added a little rubber, see if I can get that, it's kind of heavy, little rubber feet on it so that it helps reduce vibration, and that works very well. Yeah, so that's about it on this front. Stay tuned.